In this video, we'll talk about frequency polygons. Here we have a histogram. This histogram is representing people of different age groups in a particular area. So here we have about 40 people in the age groups of 0 to 10. We have about 60 in the age group of 10 to 20, 20 in the age group of 20 to 30, 100 in the age group of 30 to 40, and about 60 in the age groups of 40 to 50. Now, this same data can be represented in a slightly different, visually different way. Let's see how. So here I have the same histogram, and what I'm going to do is I'm going to join the midpoints or the tops of these lines. Let's see how that looks like. Let's join them. And let's remove this part. And here, this is what we call as a frequency polygon. A polygon is a closed figure made up of multiple line segments. And that's exactly what this is here. So this is a closed figure, including the x-axis, is a polygon. Now, frequency is the number of times a value occurs. For example, here we have about 40 occurrences of people in the age groups of 0 to 10. If you went to the area and counted people, you would count about 40 people in the age groups of 0 to 10, and you would count about 60 in the age groups of 40 to 50. And that's what this polygon is representing. That's why it's known as a frequency polygon. But we already have a histogram to do something very similar. Then why do we need a frequency polygon? Let's see. Here I have the data of two different areas. So this is one area and this is another area, and you can see that the distributions are different. If you just look at these two graphs at a glance, you can see that this is better for giving a general trend of how the things look like. Just at a glance, right? The general shape of this curve is better and slightly cleaner to look at, and gives you a simpler idea of what the general trend of the data is like, right? So it's increasing this way, and this you can see that it's reducing and then it's again increasing. And another even more important use case is if we try to compare both at the same time. So if I try to combine these two areas, now you can see that the data of the previous area is completely hidden. So we are not able to see that at all. So it's not possible for me to compare these two here. But if I combine this, now I can clearly see how we can differentiate these two data sets. You can see that it's exactly the same over here between 10 to 20 years, and it peaks here while this peaks over here. It's much easier for me to make a comparison in this case. And that's the bigger use case of a frequency polygon. And another important difference between histograms and frequency polygons is a histogram, you can see that it's a line here. I have to draw a line to represent this particular data set. So for example, if I have to say that 10 to 20 is about 60 people, I'm going to put a line at 60 and make a box like this. But here, in this case, you can see that it's a point. So I put a point. But how is it that I'm able to convert an entire interval into a singular point and figure out a coordinate over there? That's where we need to learn how to draw a frequency polygon. Let's do that. This is a area, let's say it's area A, and we have the ages of different people in different age brackets. Now, as we just saw, we need to find coordinates. We need to find an x and a y coordinate for each point to plot our frequency polygon. The y coordinates are pretty straightforward. The frequency is always going to be represented on the y-axis, and these are our y coordinates. These are our y coordinates. We need to find the x coordinate. To do that, we need to find one point in this entire interval, and that point has been chosen to be the midpoint. It's also called the class mark. It's just another name given to represent the midpoint of these intervals. Now, how do we find the class mark? There is a particular formula that's been told, which is the lower class limit plus the upper class. This is the lower class limit, and this is the upper class limit. The lower class limit plus this is a class. So this is the lower class limit and this is the upper class limit. The simplest way to think about it is just add these two numbers and divide them by 2. That's all you need to do. You might have to remember this formula for your exams, but the actual idea behind it is simply to add the two numbers and divide them by 2. Now let's do that. So what is 0 plus 10? 10. 10 by 2 is 5. That's our first point. And then second point would be 15. Similarly, third point would be 25. And the fourth point would be 35. And the fifth point would be 45. And there we have our coordinates now. So our coordinates would be 5, 4, 15, 8, 25, 16, 35, 14, and 45, 8. These are all our coordinates. Now let's start plotting. So as I said, the x-axis will always be the class or the interval, in this case which is the age, and the y-axis will always have the frequency. In this case it is the number of people. Let's start plotting. And this is our origin, and our intervals are going to be, we have chosen intervals to be 10, 20, 30, 40, 50 because we have those as the intervals here. And here we have chosen all even numbers because fortunately are in even numbers. Now let's start plotting. So first point is 5, 4. So 5, 4, this is where our first point would be. Let's plot that. And the next point is 15, 8. 15, 8. It's going to be over here. And the next point is 25, 16. That's going to be over here. And the next point is 35, 14. 35, 14. That's going to be over here. And the next point is 45, 8. It's going to be over here. Now let's join them. Right. But where is our polygon? The polygon is supposed to be a closed figure, right? We have to figure out a way to join it to our x-axis. The way we do that is by adding one extra interval before and after our first and last interval. So 0 is the starting and 50 is our last stage, right? So, but we need to figure out one before and one after. Because we want to join it to the x-axis, we need some class which can help us join our point to the x-axis. So all of our intervals are in sections of 10. So all these are in differences of 10, right? So 0 plus 10 is 10, 10 plus 10 is 20, 20 plus 10 is 30. What number when added with 10 gives you a 0? So what plus 10 gives you 0? It's minus 10, correct? So and this is going to be 60. So we're going to find the midpoint here again. Midpoint of this is 55. So we'll plot that, and join these two lines. And there we have the frequency polygon. And that's about frequency polygons. See you in the next video.